Welcome to July's Leetcode challenge. Today's problem is island perimeter. You are given a map in the form of two-dimensional integer grid where 1 represents land and 0 represents water. You can see it here, and basically inside this 2D grid there's one island. Our job is to find the perimeter of this island. Now this problem reminds me a lot of the counting islands problem, which does a depth first search to count the number of islands that are connected. But simply getting the number of cells that are islands that are connected isn't going to give us the perimeter, right? Because it depends on the shape of this island. So how can we calculate the perimeter? Now, looking at this image, it gives you a big hint with these yellow bars here. So take a look at like this island. You can see that if we were at this island and we want to check up, down, left, right, if it's outside the border or the next touching cell is of water, we can add a perimeter, a border perimeter, because you can add 1, 2, 3. If it's another island, continue to depth first search to see if it's another island that connects it, and depending on whether we visited this island or not, we want to just count up all the points where there's going to be this yellow border here and add those up, which is going to give us the total perimeter of this one island. We know there's only one island, luckily, so we don't need to worry about other islands being here. Yeah, so why not just write a depth first search algorithm, check to see if it's an island, and if it is, call this depth first search. We can write a helper method. In that depth first search, if we reach a point that's outside the water or the cell is a water, then add 1 or return a 1. Otherwise, if it's an island, we just continue that depth first search, and we'll mark the islands that we visited by changing it to a 2. There's nothing to say here that we can't mess with our original input, so let's go ahead and do that. So first, let's write a depth first search helper method, and what I'm going to do is pass in the row and column. Now, the very first thing we want to say is, all right, if this, before that, let's initialize the width and height. So the height is going to be the length of grid, and the width is going to be the length of grid 0. Okay, so if r is less than 0, or r is greater or equal to n, or c column is less than 0, or c is greater or equal to m, so it's outside the grid, then we'll return a 1. But we'll also make sure that if this point inside the grid, if it's a water, let's also return a 1. Now, depending on whether this is an island or not, we need to figure that out to know whether we want to recall this, continue our depth first search, right? So if this grid is equal to an island, then call this depth first search for all the for up, whoops, for going up, going down, going left and going right. So far, like, the format is pretty similar to how you would do a normal counting islands problem, but we want to make sure that we want to return the total number. So we'll return the sum of all 4 of these. Now, one thing to note, we need to mark the island if we've already visited. So let's just mark it as 2. That way we know, like, we visited here and it's not going to do an infinite loop. Otherwise, if it's if we visited here, we'll know that because it passes both of these, we'll just return a 0. So great. Now all we need to do is do this for the entire cell, right? And we can just say for r in range of n, for c in range of m, if the island, if this point is an island, then call our depth first search. And what we'll do is initialize a variable here. We'll make that equal to 0. And we'll add whatever we return from this helper method. And that's going to go through every single cell. So this should be a O of n solution, O of n times m solution. And finally, just return the perimeter. So this should return 16. It does. Let's go ahead and submit that. And there we go, accepted. Now, I did see on the discussion boards some more tricky ways, much faster ways to do this, but this is the most intuitive and understandable to me. So I don't think all those weird one-liners and like using all these helper methods is necessary. You could like, I don't know, do some sort of like zipping and mapping, but I think this is fine. It's a big O of n times m solution. So thank you very much.